So I had a question about how to make an envelope last a specific amount of time. So there was a question where I asked that we make an envelope that lasts for 10 seconds. Um, and the intent by that is to be able to decide how long we want an envelope to last and make conscious choices around that. So the way to approach this is to think about um, when we're building our envelopes um, with VLine, to be able to say, how long do the ramps that I'm creating take. So I'll make a VLine object and a message box. So the question here is, you know, we're kind of determining, the amplitudes that we want to go to and how long we want to take to get there. So let's say I wanted a fairly slow attack here of 1 second. So with VLine, I've got three inlets. I've got an inlet with the destination value, an inlet for the time to take to get to that value, that um, destination value. So destination is the first inlet, time to get there is the second inlet, and then the third inlet here is a delay. So how long should VLine take to start whatever ramp we've specified with the destination value and time to get there. So if I want to go to 0.8 in 1 second, that's 1,000 milliseconds. So this inlet takes um, takes a time value in milliseconds. So we know that 10 seconds is going to be really going to be 10,000 milliseconds because we know VLine takes a value in milliseconds. Okay, so we can say start that right away. So this is a list. So I've got a list with three elements, and because it's in a message box, I can just say, you know, this value is going to correspond to the first inlet. This value in the list is going to correspond to the second inlet, and the third value in the list is going to correspond to this inlet. And we know that VLine, those values mean destination value, ramp time, and delay. So when this message box is triggered, this is going to start right away because it has a delay of 0. It's going to take 1 second to get to a destination value of 0.8. Now, another thing that we know about VLine is that we can give it multiple lists. And so to do that, we separate each list with a comma. So I can give this another list, and let's say I want this to be a decay. So if this is an attack, and the attack goes to 0.8, a decay would have to be something less than 0.8. We don't have to build envelopes that way. They're value. It's a valid envelope to increase from 0.8, but that's not really an ADSR. So if I want to construct an ADSR, it's got to be something less than this because I'm decaying to it. So let's say 0.5. And let's say we want that decay to be 2 seconds. And these are values. These could be much shorter or these could be longer. But I'm making a long envelope here. So 1 second here, 2 seconds there. Let's say if I did this, think about what would happen. So when this message box, when we click on it or it's activated some other way, it's going to send this message and then immediately after that, it's going to send this message. So, well, this list and then this list would be a better way to say it. And what that means is that, so this, we've started this ramp, so we start this ramp immediately, and we said, hey, take 1 second to get all the way to 0.8. And then immediately after that, we say, take 2 seconds to get to 0.5. But this message comes immediately after this one because they're sent virtually simultaneously, but this one's first and this one's second. So this one kind of overrides this one. So this one, before we can get very far at all, we're saying go to 0.5 in 2 seconds. And so that's what happens. This pretty much doesn't happen at all. And then we start ramping towards 0.5 in 2 seconds. So to prevent that, that's why we need a delay here. And our delay should be, it should take into account how long did this take. So this took 1 second. So we want to delay this portion of the ramp by 1 second. So we can say ramp to 0.8 in 1 second. And then after that, after 1 second, ramp from 0.8 to 0.5 in 2 seconds. And so now we really actually have an attack and a decay. So what about a release? So for a release, if we're building an ADSR, goes to 0. Now we could make several parts of this envelope, but for a real ADSR, all we really need are 3 lists. So we've got an attack, a decay, and we've got a sustain. Our sustain is just going to be holding this value for some time. And since we have a delay parameter, we can just delay the release by some amount of time that gives us a sustain. So we want to go to 0. Let's say we want a really long release, 5 seconds. Okay, so 5-second release, 2-second decay, 1 second attack, so 5 seconds plus 2 seconds plus 1 second. So that means we've got 7 seconds so far of time. So with the release here, we have to account for how much time these, the attack and the decay took. So altogether, this attack and this decay took 3 seconds. So we could say, 3,000 here, and then we would have attack, decay, release, but no sustain, because now our release is starting directly after this decay. And also this envelope now is only taking 8 seconds. So what could we do? We could increase this delay. So now we have a 1 second attack. After that 1 second attack, we have a 2 second decay. And then our release starts, 3 seconds have passed, and our release starts after 5 seconds. So that means that our sustain is actually 2 seconds, and then our release is 5 seconds. So 1 second attack plus a 2 second decay plus a 2 second sustain plus a 5 second release equals a 10 second envelope. Now, there are tons of different ways that you could do this and come up with an envelope that lasts this amount of time. But any of them, you're going to have to take into account how long does each of these things take, and so how long will a delay take, and so how much time has elapsed, and what delays do we need at each stage. But this is a 10-second envelope.